Hi students, this is Dr. Spellman and we're going to take a look at some more informal fallacies today. We're looking at chapter 3.3 from the Hurley textbook and we're going to talk about fallacies of weak induction. In particular, we're going to look at the fallacy of appeal to unqualified authority, appeal to ignorance, hasty generalization, false cause, slippery slope, and weak analogy. Before we look at those fallacies, we want to review some of the definitions we looked at last time. So first, definitions of informal fallacies. What's an informal fallacy? Well, informal fallacy is a fallacy that occurs, right, an error in reasoning that occurs when people endorse arguments with weak or false premises. Again, informal fallacies are contrasted with formal fallacies where there's a problem with the structure. In an informal fallacy, there's no problem with the structure of the argument. The problem is rather that it's got a premise that's weak. Last time we looked at fallacies of relevance. Fallacies of relevance occur when the false or the weak premise of the argument is maybe not utterly irrelevant to the truth of the conclusion, but it just doesn't really bear on the truth of the conclusion. Today we're going to look at fallacies of weak induction. And a fallacy of weak induction occurs when the false or weak premise of the argument, though relevant to the truth of the conclusion, isn't strong enough to justify acceptance of that conclusion. So, unlike the fallacies of relevance, fallacies of weak induction are arguments where the premises are relevant to the conclusion, they're just not strong enough to justify it. So the first fallacy we're going to look at here, fallacy of weak induction, is the appeal to unqualified authority. People commit this fallacy when they use the testimony of someone who's respected as evidence for some conclusion, even though that figure isn't an authority on the relevant topic. So, as we can see from this diagram, right, someone's citing an authority figure as evidence for the conclusion, but that authority figure is not qualified in the relevant area. Consider this argument. Neuroscientist Sam Harris says that science can answer questions about morality, so it must be true. In this argument, the arguer is appealing to the fact that Sam Harris is an expert in neuroscience to draw the conclusion that science can answer questions about morality. But whether or not a particular field can or can't answer questions about morality is an area that philosophers or ethicists are experts in. It's not clear that neuroscientists have any particular specialty or any special insight into whether or not science can answer ethical questions. So this argument's a bad argument because it's not appealing to the right kind of authority. Now that's one way an appeal to an unqualified authority might crop up. Here's another one. So something like a conspiracy theory. For example, the coronavirus was created in a Wuhan lab and was released by the Chinese government to destroy America's economy. How do I know? Because my uncle, who spent time in China, told me so. Of course, the fact that your uncle has spent time in China gives him some insight into what China's like. It doesn't make him an authority on where the coronavirus came from or whether or not the Chinese government was involved in creating it. Presumably it wasn't. So this, again, is a bad argument. It's appealing to the wrong kind of authority. The next fallacy we'll look at is the appeal to ignorance. People commit this fallacy when they suggest that a conclusion should be denied because no one's proven that it's true, or that a conclusion should be accepted because no one's proven that it's false. Here's an example. No one's ever proven that genetically modified foods are safe, so they mustn't be. Here someone's arguing maybe that you should choose organic foods, right? And the evidence for that is that no one's ever proven that genetically modified foods are safe. Let's take a closer look at this argument to see how we might translate it into a valid argument structure. So here's the same argument again. No one's ever proven that genetically modified foods are safe, so they mustn't be. Now, if we're going to put this into a valid argument form, we want to identify the conclusion. That's right at the end of the sentence, after the so, right? So is a conclusion indicator word. they mustn't be. What's that saying? They, referring to genetically modified foods, must not be what? Must not be safe. So that's our conclusion. The beginning of the sentence is the premise, or a premise. Right? So we get, no one has ever proven that genetically modified foods are safe. Conclusion, therefore genetically modified foods are not safe. So the question is, how do we get from premise 1 to the conclusion? And that's with this implicit premise, right? The claim that if no one's ever proven something, then that thing's not true. So that argument's valid if the premises of that argument are true, and the conclusion's also true. And the first premise is true. No one's ever proven that genetically modified foods are safe. And so if there's a problem, it's got to be a problem with premise 2. And that in fact is a problematic premise. It's weak because maybe the fact that no one's proven something is maybe some sort of evidence for its falsity. It's not sufficient evidence. And so the appeal to ignorance is that second premise there, which is a problematic premise. Now we'll see that we could use the exact same style argument to argue that genetically modified foods must be safe, right? We might say, no one's ever proven that genetically modified foods aren't safe, so they must be. And this just goes to show why the premise in question is weak. It's because we can often use it to prove both that genetically modified foods are safe and that they're not safe, and so that's not a good premise that we want to appeal to in any case. Now the next fallacy we're going to take a look at is hasty generalization, or what's called converse accident. So it's called a converse accident because it does sort of the opposite thing that an accident does, right? So what an accident does is it starts with a generalization and it applies it to all cases, even the rare outliers, which is a problem. Now, hasty generalization, a converse accident, it starts with a bunch of particulars or a few particulars and draws some generalization, but maybe those particulars that we're looking at aren't similar to sort of the larger body of a population or some evidence base. So we commit the hasty generalization fallacy when we use data from some small or unrepresentative sample as evidence for a statistical claim about the whole population. So here we've got a picture of a driver saying all sports car drivers are so aggressive, and it's just to highlight that while we might be able to pick out only a few interactions with people who drive sports cars, and maybe all those interactions are ones where the sports car drivers are driving dangerously, we really shouldn't be drawing some generalization about all sports cars drivers. That conclusion isn't supported by the evidence. So one example of this might be an argument where you say, well, I've seen a few swans and they've all been white, so it must be that all swans are white. But of course we know that there are black swans, and so that argument's not good. Similarly, maybe you say, well, every raven I've ever seen has been black, so I guess all ravens must be black. That inference isn't correct either. Now, maybe the fact that we've seen a lot more ravens than we've seen swans gives us more evidence, or gives us sort of stronger reasons to think that all ravens are black. But it turns out that there are some albino ravens out there, and so here's a picture of one, right? So this gets at a bigger problem about the problem of induction and the fact that we can never draw some generalization from a bunch of particular instances. Really, to be sure that no ravens are black, we would have to go around and find all the ravens, and only then could we be sure that all ravens were black or not. The next fallacy is the fallacy of false cause. People commit this fallacy when the link between their premises and the conclusion depends on the existence of some non-existent causal connection. So what they're drawing some conclusion about is that there's some causal link, but that causal link doesn't really exist. There are a few ways to commit this fallacy. So one way is coincidence. After helping an old woman across the street, I found a $20 bill on the ground. Obviously, the universe wanted to reward my good deed. Well, this here is just a coincidence. It's not that the universe was sort of, putting a $20 bill there for you to find because you had done a good thing. Rather, you helped the old woman cross the street, you found the $20 bill. Just sort of a lucky coincidence. Another one that we maybe see in popular culture, right, is this inference from the fact that my child started showing signs of autism after I got a vaccine, to the conclusion that vaccines cause autism. So this, no one can deny the strength of the psychological evidence here, right? If you have your child and the child seems fine, they get a vaccine, days later they start showing signs of autism, you might think, yeah, it must have been the vaccine that caused autism. And I don't mean to suggest that the vaccines are not dangerous at all, right? There are side effects of vaccines sometimes. But the scientific evidence suggests that vaccines don't cause autism. And so this just appears like it's a coincidence. There's not actually any causal link going on here. Another kind of false cause fallacy is the post hoc ergo propter hoc. So after this, therefore, because of this. So here's an example. Every time school is canceled the night before classes, it snows. It must be that canceling school causes it to snow. Now here we're seeing that somebody's saying that because the thing happens after some other thing, the first thing must be causing the second. But really we know here that what's happening is that there's going to be the snow, and that's why they cancel school, not the other way around. It's not that canceling school causes the snow. Superstitions are an example of this. So every time I played golf with 2 coins in my right pocket, I broke an 80. Having 2 coins in my pocket must help me play better. Here we see an example where this is actually a picture of me. And athletes are kind of superstitious. I didn't actually play golf with 2 coins in my right pocket all the time, but I did have a place, for my tees to go and my ball marker, my different repair tool. I had sort of a system worked out, and oftentimes athletes think, if they deviate from that system, that explains bad play or something like that. But really we know there's just a sort of no causal link here. Things are just showing up together. Finally, there might be some sort of common cause that explains why you're misattributing causation to a different thing. So in this example, the argument goes like this. All animals and people who live by the old toxic waste site are getting sick and dying. The animals must be transmitting some disease. So here there's this question about why are people getting sick, and the solution, according to the arguer, is that animals are giving the humans some disease. But we know that it's not that the animals are giving the humans the disease. It's the toxic waste site. It's the toxic waste site that's causing the animals to get sick, and it's causing the humans to get sick. It's not that it's causing the animals, which is causing the humans. Here's another one. Whenever the mercury in the thermometer rises, I get warm. Rising mercury must give off heat. Again, the reason that the mercury in the thermometer is rising, the reason you're getting warm is this third thing, is that it's getting hotter in your house or whatever. And so it's not that the mercury is giving off heat, it's that the heat is impacting you and the thermometer at the same time. The next fallacy is the slippery slope fallacy. We get this fallacy when we use the fact that something could cause a chain reaction that results in disaster as evidence for the conclusion that we should avoid that thing. And in particular here, we're looking at cases where there's just no good reason to think that this chain reaction will occur. The slippery slope style arguments can be good arguments, right? If we are in fact on a really slippery, if there's a really slippery slope ahead of us, we better not get onto the slope. That's really important. But if the slope isn't really all that slippery, or we're not really very close to where the slippery slope is, then these kinds of arguments are not very strong. So here's an example. If you let your baby sleep in your bed, then it'll want to sleep in your bed every night for the rest of your life. You'll never get a good night's sleep again. As someone who's a parent to a few young children, this argument is tempting from time to time, right? It's tempting to think, oh man, if I let them sleep in my bed on this night, then they're going to be back in here the next night and the next night and forever. But it is important to remember, and my wife, reminds me that just because we're letting them sleep in our bed one night doesn't mean we're going to have to let them sleep in our bed every night. And so it is possible to draw a line. Here's another place we might see this sort of slippery slope crop up. People say things like this. If we give handouts to unemployed workers, then everyone's going to quit their jobs and America's economy is going to crumble. Now, it might be true that if we give handouts to unemployed workers, there might be some people who are less inclined to get a job than they would otherwise be. But it's not true that everyone's going to start quitting their jobs. Will America's economy crumble? That's a good question, and this is a legitimate issue that is worth thinking about. But this argument sort of overstates the point. It makes it sound like, if we give any unemployment benefits, then America's economy is going to crumble. And it just seems like that is suggesting that it's too slippery of a slope. The last one we're going to look at is the fallacy of weak analogy. So people commit this fallacy when they use an analogy to draw some conclusion, but the analogy isn't strong enough to support it. So here we've got a picture of an apple and an orange, and the thought here is like, well, we're comparing apples and oranges. We really shouldn't be drawing an analogy between these two things. Here's an example. My last mathematics professor was tall, bald, and knew a ton about math. My new landlord is tall and bald too. I bet he knows a ton about math as well. As we know, the reason that the mathematics professor knew so much about math didn't have anything to do with the fact that he was tall or bald. Tall and bald people aren't all math whizzes, or something like that. So the fact that the new landlord is tall and bald, while that is something they share with the mathematics professor, it's not very good evidence that your landlord knows much about math. Here's another one. You might say, my house has a basketball hoop, a big yard, and an outdoor pool. My friend tells me that she also has a basketball hoop and a big yard. I'm sure she has a pool as well. I'll be sure to take my swimsuit over when I visit this summer. Now, again, the fact that someone has a basketball hoop, a big yard, an outdoor pool isn't particularly good evidence that other people with basketball hoops and big yards are going to have outdoor pools as well. There are a lot of people with basketball hoops. There are a lot of people with big yards, but way fewer people with outdoor pools. And so the fact that these two things are similar between the two houses is not especially good evidence that your friend has a pool. Alright, that's the end of our lecture today. I'd encourage you to turn to page 154 and answer some of the practice problems there. And then, go ahead and check your answers when you're done to make sure you're getting them right and you're on the right track.